Hello, my name is Evie, and I'm a first-year engineering student studying creative technology and design at the University of Colorado Boulder. Today's lesson is all about electricity and circuits, and I have HelperBot here, who's a robot with their own parallel circuits, to help out. Have you ever had one button on your controller stop working while playing video games, or a single light bulb on the ceiling go out while the rest stay on? Today, we're going to learn about why that is. It has to do with the circuitry for an electronically powered object. But first, a refresher on series circuits. Series circuits have all of the powered objects connected to each other. This means that if one object is disconnected, then all of the objects are also disconnected. For example, if we have some light bulbs connected like this to a battery, they're all powered. But as soon as you take out one of the light bulbs, the circuit becomes an open circuit, and the energy current can't flow through it. This means that all the light bulbs are now unpowered. Parallel circuits, on the other hand, help to prevent all of the light bulbs from turning off when one goes out. A parallel circuit ensures that the circuit stays closed so the energy current can continue flowing. This is done by dividing up the current between powered objects with more connections, so if one is disconnected, energy can still continue to flow to the others. Engineers often utilize parallel circuits to ensure things can stay working, even when one thing might go wrong. HB actually has parallel circuits inside of them. Sometimes the light for one of their eyes will go out, but the other will stay on, so it looks like they're winking. Oh, just like that. Haha, let's get that fixed up real quick. HB's eye has been fixed. Now we can play a little game called series or parallel. HB here will show you a few circuits, and you can pause the video to figure out if the circuit is a series or parallel circuit. Ready? Go! It's a parallel circuit. It's a series circuit. It's a series circuit. It's a parallel circuit. Great job! Now you know the difference between a series and a parallel circuit. HB is proud. When batteries are in a parallel circuit, the total current produced increases, but the voltage stays the same. This is because there is more than one path for the current to flow through, so it is divided between the powered objects. The resistance of a circuit is decreased as more paths are added to a parallel circuit as well. If an object has more resistance, it also has less of a current running through it. Circuits have many different symbols that can be used to represent different aspects of one. Here's a quick and easy diagram to show you what all the symbols look like. I'll leave it up on the screen for a few moments so you can take a look at each one. We can find the electric power of an appliance with the equation P equals I times V. P is the power in watts, I is the current in amperes, and V is the voltage in volts. We typically know the voltage of an appliance since it stays the same no matter what, but for a parallel circuit, the current changes due to all the different connections. This means we'll have to find the current, or I, before we can plug it into the power equation. For this, we use Ohm's law. The equation for Ohm's law is I equals V divided by R. I is the current in amperes, V is the voltage in volts, and R is the resistance in ohms. Let's work through an example. Here we have a parallel circuit. We can see that the total voltage of the battery is 20 volts, and we have 3 different light bulbs that the current is being distributed to. For the first one, the resistance is 2 ohms. We can plug this into the equation, so we get I is equal to 20 volts divided by 2 ohms. This means we have 10 amperes. We can do this for the rest of the problems as well. Just plug in and solve. This gives us 4 amperes for a resistance of 5 ohms and 2 amperes for a resistance of 10 ohms for the other two currents. Now we can figure out the amount of watts by plugging each different value of I into the power equation. We get 200 watts for the first one, 80 watts for the second, and 40 for the third. We can add them all together to get the total power, which is 320 watts total. Now you know the difference between parallel circuits and series circuits, how they work, and how to find the total power of a parallel circuit. Isn't that awesome? Engineers get to be very creative in making these appliances with all the different ways they're able to connect circuits together. They design thousands of parallel and series circuits that work together to create integrated circuits. You can find these circuits in all sorts of things, from toasters, to houses, to controllers, to iPhones, and more. It's like a weird kind of puzzle that ends up being pretty useful. I encourage you to try and draw your own circuits using the symbols previously shown in the video. Then, perhaps you can build your own, using the knowledge you just gained. Maybe one day you can make your own HB. Or just make a different robot. HB is completely unique after all, no one could replace them. Anyways, that's all for today. Thanks for watching, and we'll see you next time. Check out the full lesson on the TeachEngineering website. Then, check your knowledge of parallel circuits by building and modifying your own parallel circuit in bulbs and batteries side by side.